Welcome to Brain Vision.
In part A, we want to figure out the max acceleration that we can apply to the boulder through the chain so that the chain does not break. Now we're told that the max tension of the chain is equal to 2.5 times the weight of the chain. And we know that the weight of the chain is equal to the mass of the chain times gravity. Now, the mass of the chain is given to us as 575 kilograms, and g is a known constant. So this gives 14,088 newtons of force before the chain can break. Now, if we draw the force diagram for the boulder at the bottom, we have the force of tension upward, and we have the mass of the boulder downward. We also have an acceleration upward. And so the sum of the forces in the y direction is equal to the mass times acceleration in the y direction. This implies that t minus mb, a minus sign because it's in the opposite direction, is equal to mass of the boulder. Oh, I messed up here. It's not mg, it's mb, mass of the boulder, is equal to the mass of the boulder times the acceleration. And so the acceleration is equal to t minus mass of the boulder times gravity over the mass of the boulder. And so we just solved for the tension up here. We know what the mass of the boulder is. It's 750 kilograms. And we know g. And so we can plug in those numbers and we get that the acceleration, the maximum acceleration, because we use the maximum tension here, is 8.98 meters per second squared. And that's the answer to part A. For part B, we need to use a kinematic equation. We know that the distance we have to travel, y minus y naught, is equal to 125 meters. We know that the acceleration during this time is 8.98 meters per second squared. We know the initial speed is 0 meters per second. We do not know the final speed, and so we have to use a kinematic equation that does not involve this. Our true unknown that we're trying to find is t. And so the one we're going to use is the one that doesn't involve v. Which is this one here. Now we know the left-hand side is 125. Our initial velocity is 0. And our acceleration is 8.98. And so we get this. Solving for t, we get 5.28 seconds. And that's the final answer to the problem.